Wait for it to make the boop boop noise. Come on, there it goes. And so, yeah, it tells me once it's actually actively recording. So once again, the opener, it is all three types of rocks that can make metamorphic. Originally, metamorphic was created by igneous, which weathers down to make sediment, which creates sedimentary, which is pushed down, and then the original metamorphic rocks were a combination of the igneous and the sedimentary, but now it can be all three. You need high temperature and pressure, but not reaching the molten status, because if it is molten, we go back to the beginning of the cycle where it's going to have to create an igneous rock mix. It comes up, it weathers, it makes sediment, it buries down, and now we have combinations of all three. When you're getting deep enough in the earth, so you have enough pressure, and as we go deeper in the earth, about somewhere around 7 to 10 kilometers, depending on where you are going deep into the earth, you're going to start having metamorphosis. And they look different. So there's different words. Unfortunately, it's a lot of Latin again. Did you ever say, can you go back? Did you finish? Or did
Yeah,
you did? So metamorphism, I can say that easily. You have an original rock. Okay, we call that the parent rock. Or the protolith, there's a scientific phrase for it, into a new rock, which we call a daughter rock. It's not sexist at all, but there's no son rock, sorry, it's daughter rock. It's like in biology, there's daughter cells, it's the language of it. And chemically, it's going to have the same components, they've been stressed in some way, shape, or form because of the pressure. Plate tectonics drives a lot of this too. And there's a couple of new phrases. They're either foliated or they're non-foliated. We'll get to those in just a second. But your most important thing in driving this is heat. Like I said, not molten, but as we go deeper into the earth, we increase the temperature. We're getting closer to the mantle. And every kilometer we go down, it's approximately 25 degrees, give or take 5 degrees on either side. Increase in temperature in Celsius, or technically Kelvin. They actually, Celsius and Kelvin runs on the same scale. It's just Kelvin is a difference of 273.15. But they still, each jump is worth 1 on the same scale. It's not true between Celsius and Fahrenheit. No, I'm not going to make you convert stuff like that. That's chemistry. And this is where I changed from my original slides and I moved stuff around. You don't have this chart. I didn't even put this chart on here until this morning. But we have a geotherm difference between your continental crust, okay, which is what we walk on, okay, and your oceanic crust, which is underneath the ocean. And in general, the geotherm is higher with the land mass, with the continental mass, than it is with the oceanic. And there's all different kinds of reasons why. It has to do with water content and has to do with the pressure of the ocean. But in general, what this means is as you go deeper on land, the increase in temperature is more exaggerated than it is in the ocean. And the reason why is because the radioisotopes are concentrated on the land mass, the continental land mass. They're not underneath the ocean. I'm not saying that there's not any there at all, but as you go down, let's just say 2 kilometers on the land is going to have a certain temperature increase, which will be much, much higher than it would be if you're going down, swim down to the bottom of the ocean and do the same 2 kilometers down there. There is an exception. If you're doing this at a ridge, you're already closer to the magma. So there is an exception to that. If we're talking about going down in depth at the ridges where you have volcanic activity underneath the ocean, you're going to have an increase of temperature that's faster compared to that's on land. That's the exception to this. When you have your metamorphosis, the creation of the new rock, the recrystallization, you're going to have bigger grains, coarser grains, and you're going to have more stable isotopes or minerals or rocks. And I'm not gonna make you like memorize this chart, but none of you guys can't see me pointing at the board. Okay, so this one right here is your continental. So if I go at a depth, so to get to 400 degrees, let's see here, it's about what, 20 kilometers down, give or take. But to get to 400 degrees, I have to go, I'm trying to go straight down. It's not, I said give or take 50 kilometers down underneath the ocean. The temperature increases quicker with depth on dry land, continental land, than it does underneath the ocean. Two major sources of heat. Contact means touch. If the coast rock, if the country rock, the sedimentary rock, stuff on the surface, if you have an aerial, which is an igneous intrusion, okay, the magma's trying to come up, on the edges of that, you've never noticed it looks like little hairs sticking out? That's contact metamorphosis. Doesn't mean that it necessarily melted, but when it was close to the edge of that, a sill or a shunt, close enough to it, you had enough increase of heat that you had direct contact through the rock, enough heat, enough pressure, and it causes metamorphosis. Regional means that it's gone deep enough in the earth, and as you go, I just showed you the chart, as you go deeper into the earth, you have an increase in temperature. Regional metamorphosis is the most common type. And now there's types of that, but this is the most common type. As you go further down towards the core, where it's really, really, really hot, you're going to have an increase in temperature. And like I said, the continents increase quicker with depth than below the ocean. Let's see, what else is in here? Anybody still need this one, or are you ready? No? All right. So there's a couple different ways to say these. Uniform versus directed. As you go deeper, you're going to have an increase of pressure no matter what. Confining pressure, which is the uniform type, which is also lithostatic. There's multiple ways to say the same thing. You have uniform just means the same. Okay, everything is the same. So that means that the pressure is applied equally from every direction onto the rock. It's trying to squish it down equally from all sides or all directions. Whereas directed pressure, it's exaggerated on one plane more than the other. The differential or the directed, this is what causes foliation. It stresses it, it deforms it. It wants to squish it, basically like funhouse mirrors. It either wants to stretch you this way or it wants to stretch you this way. I can't remember which is which. One is convex and one is concave. Concave goes out this way. Convex brings in this way. That's how those mirrors work in the funhouse. It's been a long time since I've taught that. That was when we shut down for COVID. That part, oh, made me so mad. I love teaching optics and light. And I make all my students hallucinate in the classroom. They're like, you can't make me do that. I was like, oh, yes, I can. Watch the board.
I want to hallucinate.
You want to hallucinate?
You were just talking about it, right?
Mm-hmm.
Is it legal?
Yeah. You think I would seriously do something illegal? Really?
Know.
Oh my God. Oh. Swear. No, it's just, it's optics. It's light making your,
Do it.
I can make it, when you look at something else, I can make it look like it grows. I can make it look like it shrinks. I can make it look like it spins.
Can you do it now?
No, because we're doing this right now. We get through quick enough, I can show you. No, that's physics, that's optics.
You can grade us on how we trip.
Oh my gosh, no. Okay, so,
Oh,
what?
one question said, which type of pressure, has the equal? So that one is like,
Okay, so let me look. I didn't put the notes page in front of it. Let me grab one.
should be down right there.
I think it is. I need to see how it's asked. Are you talking about on the assignment or?
Yeah,
Okay, unequal is differential stress, okay, but I'm gonna come back and I'm gonna give other phrases for some of this too. So basically if that's not an answer choice, it's gonna be on the next slide. All right, so lithostatic is the fancy term for everything being pressed uniformly, the same amount of pressure all the way around the rock. You gotta figure this out. Lithos means stone or rock. Static means it doesn't change. So you have equal, one side's not more than the other, essentially is what this means. This is the fancy term for the uniform pressure or confining pressure. But there's many, many different ways that I've seen this actually worded. Directed pressure, on the other hand, this is the differential one. And you have one plane that has a lot more pressure. Could be X, Y, Z, because you've got 3 dimensions, which is down underneath the earth. And your minerals will want to align a very specific way because they don't want to break. And this is what causes what we call folds. You can see the lines. And I was hoping that one of these had a really good, what is this one? This one's 13. No. Maybe in that big box. Let me see what's in the big box. I have pictures of them, but I'm not show you an actual. It's not labeled. Oh, okay, that's really. No. All these things have tags on them, and there are no keys. Does anybody still need this one? So this is just an image of what's going on. So underneath the earth, if it's confining or lithostatic or uniform, it's sort of showing that there's pressure that's being pushed equally all the way around the rock. And it's going to end up just looking like this. You just have regular old layers that are not deformed, they are undeformed. And then if we've got unequal pressure, they're going to align themselves so that they don't snap. And this is what causes this wavy type pattern, which we call foliated. So directed pressure, the one that was on the bottom, the one that's unequal, it's more in one direction than other directions, causes what's called foliation. I don't know if you've ever heard the technical term for leaves on trees, but it's called foliage. Okay, so foliation looks like leaves, not necessarily straight. They're wavy, because you can see the different lines. You can see the different patterns. I meant to bring that one rock from home, that my metamorphic one, because you could see the patterns really, really well, because some were felsic and some were mafic, so it's just, but I forgot to bring it with me. But you should have a picture. This is an example of what foliage looks like on an exposed surface. It is a metamorphic rock. I'm looking to see if there's one that's in here that shows that. And then, maybe this is I'm just not coming across any. I said it would have been awesome if whoever had this class before you labeled this stuff, but we didn't do it. The one that I have at home does. I remember to bring it. None of these do. So your chemical composition comes from the original rocks, parent rocks, proliths, whether they be igneous or sedimentary or metamorphic. All it does is it recombines out those chemicals a different way, but it's still, you can't create all new elements if they weren't there before. Now there is an exception. If you have very hot ion-rich water, that can bring in different elements that were not there in the original rock. And its chemical component is the easiest way to determine where the heck the metamorphic rock came from. And I've got, I have a new student in one of my classes, and
Do you like one of those?
they, what? No. I had a new student from a different district, and he's a freshman, and I'm like, why are they putting a freshman, like, child doesn't have chemistry, and not that I'm gonna ask you guys to like balance equations or anything like that, but I'm like, I don't know if you made the right choice putting him in here. Oh, look, we're still sending texts like crazy. What's in here? Huh? Well, it might be something important though. You know, it's just they're having this big discussion about this COVID vaccine. I'm like, stop. But now, like if my kid's school is trying to get in touch with me because she's throwing up or something like that, I can't do that. Yeah, that's well, because they did not do something that's important for the chemistry people.
So there's no.
So there's like, yeah, there's no win-win here. Like it's like, ugh. All right. Was everybody done with that one? I think so.
Sure.
So your protolith, okay, that is the technical term for what the rock came from originally. That is the parent rock. And they're categorized, I think there's 6 of them. 1, 2, 3, 4, 5. Yeah, there's 6 of them. If they're ultramafic, and these are not new terms, when we were doing igneous is where this came from. You have high levels of iron, magnesium, nickel, chromium. If you do not know what your chemical symbols are, that's the elements that are in there. Mafic doesn't have the nickel, and you start bringing in calcium, but you still has high levels of iron and magnesium. These are your darker rocks normally. Shale. Not, I don't know what, K is potassium, yes. P is phosphorus. The Latin root is kalium for potassium, that's why it's K. But your shales start bringing in aluminum. We're getting in the silicon, so we're getting closer to the surface. You're not going to have the iron and the magnesium. Your carbonates, calcium, the carbon dioxide, calcium carbonate is CaCO2, it's calcium carbonate. We start bringing in magnesium again. Quartz is almost completely silica oxide, which this is, that's what this big guy is over here. I just know it's got some iron in it because it's got so many different colors. It's got green and purple and pinks in it, browns.
Something.
No, I'm gonna chop it in half.
Let me go to the side.
You want?
Maybe we make an iron sword.
An iron, so you're gonna make an iron sword out of quartz. And then if it has feldspar in it, it's gonna bring in sodium, aluminum. These are your lighter elements that are less dense, and therefore they come up towards the surface. So Mg is magnesium, Fe is iron, Ni is nickel, Cr is chromium, Ca is calcium, Al is aluminum, K is potassium, it's my silicone. I think I just said all of them. The CO2 is carbon dioxide. This one right here is a silicate. Silicon and oxygens that are bonded together.
Is it silicate?
No, silicate. Silicate. It's a silicate. Like I said, I'm not going to necessarily ask you to do any kind of like write out this chemical pathway, but I don't understand why they put that in an upper level class. In my 7th period. I think he was actually probably coded as like environmental systems. And they thought that like this was the equivalent, because I went to talk to the counselor and I said, no, they're not, no, they're not the same thing. All right.
Ms. Ritchie,
What?
what is geological time?
Geological time?
It says in consignment.
That was like the Mesozoic and the Cenozoic, and that was a while ago.
Oh, because I'm looking at the thing, and
Hold
there's
on.
no assignment for it. So it says, it's 11:10, but it's in the
Okay, so it would have been the 11/9 assignment that was due on the 10th, probably.
but then this is supposed to be.
No, that's when it was due. That's not when it was
That
assigned.
was actually.
So the one that was due on the 9th came from the 6th,
Mhm.
and the one that was. This was the one that was due on the 10th. I have to look, I need to go back and change so that I put that was before I started putting the actual like title next to the assignment, like the whatever assignment. Because I started getting confused too, when people were saying, hey, I'm missing this, and then they did what you just said and said, oh, I'm missing the assignment from this date. No, that was technically from the previous day, because what you're reading is the due date. So, all right, where was I at? Right, so the types of metamorphism, if it's contact, it's an igneous intrusion in some way, shape, or form. And so that you've got your inside of the earth, the molten part that's trying to come up, where that is touching rock, and within a short distance around it, there's enough heat in order to cause metamorphosis. It's hydrothermal. Hydro is water. Okay, so you have very ion-rich water, have different ions that are in it. This is the one that brings in new chemicals, new elements that were not there with the original rock, and so that was the exception. That metamorphic is just made up of the original rocks. Regional, this has to do with pressure as the rocks are being pushed down in the earth, and it's associated with tectonics and causes all different kinds of stress. And then dynamic deals with earthquakes. And then the fancy term for that is cataclastic. Yep. That is, we're starting up some plate tectonics. The test is Wednesday. This is Wednesday. So I haven't made those yet. I'm gonna end up making those this weekend. I think already. All right, so specifically contact, review each one separately, view of your igneous intrusions. We're not gonna go back over igneous again. But you have the magma that's trying to come up towards the surface that hasn't actually punched through, because then you have a volcano. The deeper magma is hotter than the magma that's closer to the surface. So the basaltic is going to be much hotter, or the mafic is going to be much hotter than the felsic, which is the granitic magma. Those are all terms that we were talking about, like the igneous one before Thanksgiving break. As you go away from that intrusion, okay, into the solid rock, the temperature is going to go down. Those are called areoles, is what those things are called. I have a picture showing what they look like if you do a cross section. A country rock is the rock that it's trying to come up through. It's like a host rock. It's what the intrusion is trying to come up through. I think there's one more. There is. And sometimes it creates something called hornfells, which I do have in here. This, yes. This is hornfells, and it's really brittle. Because it's, I know this is gonna sound like an oxymoron, it's because it's tough. And the stronger it is, the easier it is to actually crack pieces off. It can't take the stress. And this is, I see Hornfels listed a lot in questions, so we'll come back and we'll talk more about types Monday. We'll talk about some of them tomorrow with
Wait,
types.
so which type is the one that caused the,
Which what?
which one, which type? Mm,
Well, what type is listed at the top?
okay.
Yeah, this is direct. Like I said, it's not melting it. If it melts it, then it has to become igneous again. This is, so if I draw, well, I'm just gonna show the picture on the next slide, 'cause I don't want to just draw on the board. I can't see what I'm doing. So this is what I'm talking about. So you take a cross section, and we had an original volcano. And like I said, the host rock is what the intrusion is going through. It's the original rock. It's the sediments. It's what the heck the lava's trying to come up through, or magma. So you have, see how it's got sort of like a grayish, bluish, I don't know what you would call that, around where the magma is? That's where the metamorphosis is occurring. Yes.
I actually started the root test and it's ticking down.
Yeah, there's a 45-minute timer on the retest.
Is there any way to pause that?
I don't think so. It's a good part. I'll have to look. I'm not sure.
No,
I don't think.
There's not?
Nope. If you shut your computer down, you will still continue to go.
Yeah, I don't think there is a
It's
way
not like the
to.
assignment where you can shut your computer down.
So, anyways, so the aerials, they're along the edge of where that intrusion was.
Next question, I have to do my
Oh,
schedule
Lord.
too.
It even said I don't know. That's a counselor question for you. All right, so hydrothermal, this includes water that has all different kinds of ions in it, different ions. It brings new elements into the rock and it changes its chemical composition. Can't remember how many. I think that's the last one. That's on. We cheat. This happens at your oceanic ridges. These things form hot springs, geysers, mud pots. If you've ever been to Yellowstone, that's why all that activity is there, is because of this specifically. I showed some of the images yesterday. One of them, the one on the left, had to do with the mammoth, the limestone creations in the northeast portion of the park. But your magma causes, it's just like boiling water in a pot, but it's underground. It causes circulation of that, which pushes the water through the rock. So it doesn't have to happen in the ocean. It can happen anywhere where you've got magma that comes in contact with water. Iceland has lots of this stuff. Iceland sits right on top of a ridge. Yes, right on top of the ridge.
So they just go under.
Well, they use lots of geothermal energy to heat their homes and stuff. It's not necessarily going to blow up, but yeah, very few areas have enough geothermal activity. They heat their houses with it.
That's pretty cool.
So they don't have to pay like.
Well, and they harness geothermal to create electricity. It's almost like a dam, but it's not just water spinning the turbines. They use the steam, like they actually pump the steam through their house through pipes. It's like a giant radiator system.
What if they had like 100 mice running the tower in school?
100 mice running in a wheel to power the school. I don't think that would be enough to. All right, let me keep going. All right, so this is an example of hydrothermal. You have your inside of the earth, the magma, and it heats, and up underneath, it starts bringing that superheated water. Once there's enough pressure that's been removed, it turns into steam. But if there's enough pressure, it stays in the water state. That's why at the bottom of the ocean, the shrimp that live in those thermal vents, it's over 400 degrees down there. And it's not boiling because there's so much pressure. Regional metamorphosis. This is the most common type of all of them. And there's a specific sub-branch that's the most common of these. But you've got your plate tectonics. That's what lithospheric plate collision means. Plate tectonics. They're moving apart or they're coming together. In this case, they're coming together. and I have pictures of this too. You've got a belt or a zone, and you're looking for index minerals. They form from very, very specific temperatures and pressures. And as the pressure is reduced and the temperature changes, these minerals start to precipitate out, or they crystallize. They come into being. Now, I've mentioned this before, there are very large crystalline areas that are called shields underneath where the bedrock is. Our country does not have a shield. We don't have a shield anywhere. Some countries are like pure shield underneath it. China's like that. Antarctica's not a country. Antarctica's like that. There's one in South Africa. Brazil has a giant shield underneath it. We don't have the right situations. Our bedrock's limestone. Ours is not a shield. And I meant to actually put, there's like a map, I meant to put that up here and I forgot to put it in the notes. Your phone's broken.
Yes, I have to.
I don't want to run out of time. I've been bouncing back and forth with you guys and it's slowed me down. Aerial metamorphism. This is, it's not foliated, so we don't have those wavy looking lines. Dynamothermal does have the wavy lines, and this is actually the most common of the regional ones. Your plates collide, you've got stress in more of one direction than another, and it causes that curvy, snake-like looking line through here. And I've got pictures to show you how this happens. Let me double check my attendance real quick. I just realized I need to do that. Where'd it go? Where'd it go? Here it is. We got a couple pictures and we got one more slide and I need to go over who's missing what. Oh, yeah, I got more people. Let's see. I see Courtney. Oh, I already got Courtney. Well, it's not as cold as it is outside. Although it's a lot warmer than it was yesterday and the day before.
Yeah, seriously, 27.
We're getting close to the winter, y'all. I would rather it be cooler than 105 degrees and you can't breathe because it's so hot.
That's not even bad. I used to work.
We used to work in little buildings.
Okay, so now this is I got a before and after. So we have two plates that are coming towards each other. And one is going to subduct below the other. Don't worry, we don't need to know that yet. We'll start that up with plate tectonics. And when they do collide, one is going to go underneath the other. The one on the right is going to go underneath the one on the left. And when they smash together, this is what causes direct pressure. And you've got metamorphosis that is occurring where these two plates are coming in contact. This is the last one. Dynamic, this is the earthquakes and faults. This is the seismic activity. The big one here is the San Andreas fault. You think, oh, California's going to fall off in the ocean. No, it's not. Okay, if it has enough of a rift that's created, you might have ocean water that comes in and they're going to have like an inland bay sea kind of thing. It's not just going to fall off in the ocean. That's not going to happen. Myelinite is when rock is pulverized along the fault because of it's either a slip or it's a break or you've got one going over top of another. There are different types of earthquakes. And when we get into that next 6 weeks, we'll talk about the different types of earthquakes. Now, let me freeze this and get into my normal, you did not do this, you did not do that. Okay, so,
Is there any way I can do this?
No, that's way too old. Okay, hold on, let me get into this first. I did if you did not take that test from the 20th, that was shut down yesterday. If you wanted to retest, you need to contact me. Yes, what's up? Yes. Okay, so the 30th now is done. So it would help if I was in your class and not second period. Let me fix it. Come on, computer. I don't need to look and see what I can do about that test that started ticking down on you. All right, so the one that's still open from yesterday that needs to be done, Otis, both parts of it, Erica, the opener, Kale, both parts of it, Dylan, the opener, Colton, both parts of it. That was from the first. That was what, Tuesday? I keep thinking today's Wednesday. And then yesterday's, no, I keep thinking it's Wednesday. I know it's Thursday. For some reason, I don't like. Okay, the assignment from yesterday, which is open, I did not get either part from Colton, the assignment from Decker, the opener from Kale, the opener from Erica, the opener from Taylor,
If I just took those two
the
assignments,
assignment from Caitlin, both from Otis. And then that retest is open. Like I said, you needed to have contacted me. I did create it yesterday, and then I forgot to publish it. I published it this morning, so I'm sorry. I just yeah.
So big day.
Can I go see this button?
Yes, you can. All right, so I'm saving this. Okay, now let's look and see what I can do. Let me. Was it the retest that you started?
Yeah.
Okay, hold on. Let me look and see what I can do.
I'm gonna hang out in the bathroom to the door because it's so warm.
No.
That's why I said we should have class.
And so we're all gonna go into the boys' room. Yeah, that sounds smart.
Yeah.
Okay.
There is a room.
That's disgusting. Boys pee on everything.
I don't.
Uh-huh.
I got a nice stream going.
Oh, good Lord.